So at this point, we've done the hard work to figure out the derivative of sine and the derivative of cosine, and they're both over here. The derivative of sine is cosine, and the derivative of cosine is negative sine of x. Now, something that's important to remember about these is that these derivatives are true only if we're using radians. Okay, the calculations that we did to come up with these derivatives depended on the geometry of sine and cosine, and that geometry only worked if we measure our angles in radians. So it's for this reason that if you're in calculus class, you have to be using radians. It's so that the derivative of sine and cosine are what you think they are. If you measure your angles in degrees, then these derivatives are no longer true. You could fix them up, but these are so easy to remember. This is kind of the universe's way of telling us to use radians, right? Because these derivatives come out so nicely. Okay, so now that we have these figured out, let's just work out a couple examples to see how they work. So first, let's find the derivative of this function, x squared times cosine x. So because this, when we go to calculate a derivative, we have all these derivative rules. You have to figure out which is the derivative rule that I use. Well, remember that the derivative sees, since the derivative is sort of standing outside of the function, it sees the last operation. So from the derivative's point of view, what it sees is the fact that there are two things that are being multiplied. It kind of doesn't yet see the x squared or the cosine. All the derivative sees is that there are two things being multiplied, and so we use the rule for multiplication, also known as the product rule. The product rule says it's the derivative of the first one times the second one with no derivative plus the first one with no derivative times the second one with a derivative. Okay. So we still have some derivatives to calculate, this one and this one, but the stuff inside of these derivatives, here and here, is simpler now, So a lot of our derivative rules don't directly tell us our derivative, but they sort of give us smaller and smaller pieces to calculate, and then eventually the derivatives that are left over are so easy or straightforward that we just know what they are immediately. These two are definitely of that variety. So derivative of x squared, the power rule tells us the derivative of this directly. So the 2 comes down, and the exponent 2 changes to a 1. So we get 2 times x times cosine x plus x squared. And now we need the derivative of cosine x, but we know what that is. That's negative sine of x. Okay, so this whole thing is 2x cosine x minus x squared sine x. Okay. Maybe the one really common mistake with complicated derivatives like this is for some reason people really like writing down this d dx thing. And so, at this point, notice that I stopped writing it. And that's because we did that derivative, d dx is essentially a command. It tells you, take the derivative of this thing. So when we write down the derivative, 2x, we've done the command, so stop writing the command. We did it already. The mistake that I often see is, after taking a derivative like this, after writing down the final result of this derivative, some people will write the d dx again. But we don't need to do it again. We already did it, so stop writing it. If you keep writing d dx after you've already calculated your derivative, it's as if you keep writing the square root after you've already done the square root. So the square root of 4 is 2. When you write down 2, would you write the square root again? No, because you already did the square root. Stop writing the square root. You did the square root. It's the same thing here. As soon as we've calculated a final result for our derivative, stop writing d dx, because we've done it already. The reason that these d dx's show up is because the product rule has derivatives in its result, right? The product rule says the derivative of f times g, it doesn't give you some formula with no derivatives in it. It gives you a formula with derivatives in it. So the product rule doesn't give you a final result. It just tells you what smaller derivatives you have to calculate and how to combine them, right? This is very different than the power rule, because the power rule, right, the right-hand side of the power rule, doesn't have any derivatives left to calculate, right? There's no ddx's over here. So in complicated derivative situations like this, be careful to write down the derivative when you need it, but when you actually are done with it, stop writing it. Okay. So here along the way here, we used our new cosine, or our new derivative of a trig function here. As a second example, let's find the derivative of this messy function, derivative of cosine x over 2x plus 1. So the derivative sees the last operation on the inside, and according to the order of operations, the last operation that happened was this quotient. So we need to use the quotient rule. And the quotient rule says that the derivative is the derivative of the numerator, so derivative cosine. Actually, let me switch this. We did one with cosine already. Let's do one with sine. So derivative of sine, and then 2x plus 1 with no derivative, minus sine with no derivative, times 2x plus 1 with the derivative, all over the denominator squared. So 2x plus 1 squared. Okay, so our denominator is 2x plus 1 squared. And now we have a couple smaller derivatives to calculate. We need the derivative of sine of x, but we know that one. That's cosine x. So that times 2x plus 1 minus, and then the derivative of 2x plus 1. But we can use the sum rule for that and the constant multiple rule and the power rule. So sine of x times, and then the derivative of 2x plus 1 is just 2. All right, and now we don't have any ddx's left. That means we're done. We should simplify this, but I don't think that this really simplifies in any nice way. Right? If you multiply this out, there aren't any like terms, and so we might as well just leave it the way it is.